CH is true. Long time, little vacation, but I'm back. So I'm going to do a little bit more on math, and by special request of an old friend of mine, I'm going to maybe do some philosophy too. What I want to do is something a little different than the usual calculus video where they're very proof heavy. I want to see if this works to help people. This video and maybe the next one, I want to see if this works to help people understand things intuitively. This is not intended to be as a rigorous proof. Just correct something here. There we go. Okay, now we're good. So I want to see if this helps students out in their conceptual understanding. So tell me if this works. Post below if this works. Instead of thumbing it up or thumbing it down, give me some suggestions, because a lot of my videos have been about entertaining myself intellectually, and that's a lot of fun. But this one I actually want as a concrete aid to visual understanding of calculus. So we're going to talk about the product rule. The product rule states that the change of x times y. Okay, now remember, x is a function and y is a function. X is a function between t min and, let's see, we'll call it t, we'll call this t naught, t1, and t2, okay? So between t naught and t1 would be x, and then delta x would be the change of the function between t1 and t2. We'll do the same thing for y. This is y at t naught, y at t1, and then y at t2 out in the outer one. So you can see where this is heading, because as delta x goes to dx, t1 and t2 come together and they become t max. Okay, and as delta y goes to dy, t1 and t2 come together and they become t max. So this ultimately becomes between t naught and t max. But that'll be more important, let's say, when we're doing integrations. What we're really looking at is, here I'm showing that the function of x becoming x and the function of y becoming y, to make it simple and concrete. Multiplying the functions together, we get x times y. But the area shaded in here is really the change of x times y. So this becomes the change of x times y, and you can see that the change of x times y, it's a little, hopefully the lighting's good, but the change of x times y is equal to y times the change of x plus x times the change of y, plus that little area there, delta x, delta y. But you can see intuitively that as delta x and delta y become smaller and smaller, this converges on being a point. And as this converges on being a point, mathematicians have argued, and you can debate whether they're correct or not, but mathematicians have argued that that becomes more irrelevant, and that dxy, meaning the derivative of x and y, the change of x and y at the infinitesimal converges on y dx plus x dy. Now this is a limits problem. I left the limits out, but this is a limits problem? Okay, all right. There we go. All right. There we go. Okay. Makes you happy. Okay, the limit, as this is true, converges on this, okay? The derivative of x times y is equal to y dx plus x dy. Plus, if you want to say dx times dy, you can, but mathematicians leave that out, I think, because it doesn't influence the overall. Mathematically, it's useless. Especially since as you do integrations of that, you still have 0. So mathematically, the thing that you really should, hopefully, if I've done a good job, now let me know if I've done a good job, because I really want to know. Because I didn't shave today, make myself look presentable, so I want to make sure that I at least did a professional job doing this. That delta x times y, and then that y times, pardon me, that x times delta y, as it becomes smaller and smaller, shows you visually the change of the area of x times y. Okay, and this can be derived from that. So if that works for you, please let me know. This is CHistrue, and we'll hopefully do another one for you a little bit later on.